Good morning. We're going to take a look at some trig ratios. And trig is really fascinating. I mean, there are whole math classes devoted to trigonometry. So, I mean, that's pretty cool. But so today is your first step into a much larger world of math. And the amount of physics in particular that you can start explaining with trig and algebra together is really quite amazing. All right, but before we get into trig, let's take a look at some geometric means. So we're trying to find the geometric mean of 6 and 15. So the geometric mean, you'll remember, is equal to the product of those two, so h squared, or h being the geometric mean, because of course h and geometric mean go together. So we have the geometric mean squared is equal to 6 times 15, which is 90. So square root, and so we get h is equal to, well, 9 goes into that, clearly. So, and the square root of 9 is 3, so we have 3 root 10. For question 2, we're going to use this triangle here. We have PS. PS is 6. PT is 9. And we are to find PR. All right. Well, using the geometric mean idea, we know that this distance, let's call it h squared, is going to be equal to this distance times this distance. So that's 9 times x. Well, and our h value is 6, which is nice because h is turned into nice 6s. So we have 36 is equal to 9x, divided by 9, and x is equal to 4. For question 3, TP is 24, PR is 6, and we're to find RS. Okay, so if I call this A, we know that, let's call this C. Let's call this, oh, I don't know, let's call it B. So in this case, A squared is equal to B times C, right? So in that case, we want to know A squared. So we have A squared is equal to 6 times 30. So A squared is equal to 180. So square root. And we get A is equal to, well, 9 and 20. All right, so we go 9 and 20. So we get square root of 9 times the square root of 20. Square root of 9 is 3. That can be broken up in square root of 4 times the square root of 5. That's 2, so that's 6. So A is equal to 6. 3 times 2 is 6. Root 5. And finally, complete the equation. ST, so that's this, ST is equal to PT times TP. Because this squared is equal to this times that distance. So there you go. All right, so trigonometric functions. Now I'm going to take a triangle, and it's going to be a right triangle. And let's say I want to find this angle. Now, I was always taught this nice little acronym where, let's call this angle X, where is this elaborate little story about a Native American tribe, and the tribe kept chanting So-ka-toa, So-ka-toa, So-ka-toa. If you remember the So-ka-toa thing, you're going to be golden with trig, because So-ka-toa is spelled like this. This is not a Native American chief or warrior. It's an acronym. So-ka-toa, where the sign is equal to the opposite over the adjacent. And these are sides. Cosine is equal to the adjacent side of an angle over the hypotenuse. Oh God, I gave you the tangent here. h stands for hypotenuse. And the tangent is equal to the opposite over the adjacent side length. So let's call this A, B, and C. So the sine of angle x is equal to the opposite side length, so that's B, because it's opposite the angle, divided by the hypotenuse, C. Likewise, the cosine is equal to, or cosine of angle x is equal to the adjacent. Now the adjacent side of the angle is next to the angle, and so that is A over hypotenuse C. And my tangent of x is equal to my opposite over my, and you may notice on your scientific calculator you have a whole bunch of trig functions, which are really super cool. You're going to be using your calculator. Now there are two ways to show these trig functions. You can, this practice is over already?
Yeah.
Oh, I'm sorry, I thought it'd be 45. Okay, is everyone waiting for you?
No.
Oh, I'm sorry, did I mess up?
No.
All right, so with these functions, we can find angle measurements of right triangles if we know some of the side lengths. So let's take a look at this one. Now, I don't have a good scientific calculator here, so you're on your own on this, but I can do the fractions, no problem. So write each trig ratio as a fraction or decimal rounded to the nearest hundredth. And for the, let's call this angle x. So let's find the sine of angle x for cosine and tangent. So the sine is going to be equal to the opposite over hypotenuse. My opposite side length is 11 over the hypotenuse, which is 61. The cosine of x is going to be my adjacent angle, so that's 60 over my hypotenuse, which is 61. And finally, my tangent, running out of room, of x is going to be equal to my opposite side length, so that's 11, over the adjacent side length. And then what you do is you type in the ratio into your calculator and hit the tangent button. And obviously, we can work backwards too, which we'll get to. Now, let's take a look at a special triangle. Let's take a look at the 30-60 right triangle. And we know that this side length is A, this side length is 2A, and this side length is A times the square root of 2. Let's find, oh, I don't know, we can deal with the 60. So let's find the, so the sine of 60 degrees is equal to the opposite, so that is A times the square root of 2. Oh, so, oh, Jesus. I'm thinking about Anya's birthday and not thinking about the problem. Square root of 3, right? I hope you noticed that before I did. Divided by the hypotenuse, which is 2a. Well, a divided by a, well, it cancels out. And so the sine of 60 is the square root of 3 over 2. The cosine of 60 is equal to the adjacent, which is a, over the hypotenuse, which is 2a. The a's cancel out again, and so the cosine of 60 is 1/2. The tangent of 60 is going to be equal to the opposite, a root 3, over the adjacent, a. Well, that cancels out, and so the tangent of 60 is just root 3. Right now, I want you to pause the video, and I would like you to find the fractions for the cosine, or sorry, for the sine, cosine, and tangent of 30. If you haven't paused the video, pause it now. Start it up again when you have the answers. No cheating. And so here we have our answers. The sine of 30 is 1/2. It's the opposite of the cosine of 60. The cosine of 30 is root 3 over 2, the opposite, or the sine of 60. And the tangent, well, this is the only one that's kind of tricky. because we get 1 over root 3, the reciprocal. But however, you can't have an irrational number in the denominator, so you have to rationalize the denominator, and you get root 3 over 3. Pretty cool. All right, so now I would like you to try these. When you have the answers, go ahead and let's go ahead and have them checked. Okay? Good luck.